and as it did movements which resembled the circle, it received the equivalence of pleasure, and so therefore it's more and more did circular movements until it was turning around in a circle forever. So the reward systems we have at the moment are quite simple. We reward DAI for using its body, we reward DAI for curiosity, exploring the space, seeing new things, and we reward it for resting and for being excited and having bursts of energy. And with these simple rewards, DAI has a virtual infinite amount of possibilities to explore. When DAI goes to a different place, everything changes for it. So if it's on a smooth ground, the wheels will start spinning, and DAI will quickly realize that it's not being rewarded spinning the wheels this way, so it'll adjust the power delivery on its own and explore the space in a completely new way. So this is still quite far from generating art, but we're not telling it what to do. We give some simple rewards, and DAI creates his or her best way of achieving those rewards.
Yeah, it actually learned how to move by itself.
Yes, when John was saying we turned it on, this was a completely blank neural network, it knew nothing. And having had a daughter recently, it's surprising how similar it was to watch my daughter discovering her limbs and the space around her, and watching DAI slowly discover that it could turn a wheel. If it moved, things happened. If it moved in a certain way, oh, this feels nice, I'll do it some more. And to think about a computer software program as a program in this way is absolutely amazing. The less amazing thing is, this is a fantastic world. This is a beautiful world. This is pure software. Everything works. It's wonderful. Robots are hard. They're amazingly hard. It's nothing but pain. You spend hours debugging a software problem to find out that it's a hardware problem. And at the end of the day, you always know it's the hardware, and hardware takes ages to debug, and when you're cycling a real-life robot and debugging it, it takes you 100 times longer than normal software. So this is a painful, slow process. We had grandiose plans for moving DAI's brain well ahead of what we have now, but we spent an enormous amount of time getting it running reliably. And at the end of the day, it can now travel across the world and perform several hours a day fairly smoothly. So one of the things that we found interesting with DAI is that we believe that there's going to be a very, very strong impact on our world and our society over the next few years. As a software developer, I started coding when I was 12, and I've been through sort of microcomputers, the arrival of the internet, mobile computing, but I've never seen anything that resembles this. We're at a state now where there's progress made virtually every month, and the time between finding out about a new paper and seeing actual usable code on the internet which you can take and deploy has gone from months or years, even 10 or 15 years ago, to a matter of days. And this changes everything. It's incredibly exciting, but it also will have enormous consequences for our work, for our society, for culture, which are really hard to apprehend. And what always surprises me is really how little people seem to understand that when you see your first videos of an autonomous car driving on its own, now it's just become normal, and nobody seems to be really projecting what this means for the very short-term future. So DAI is our way of saying if a robot, if an AI can do art, what is left for humans at the end of the day? And we're actually working on these subjects with a foundation I co-founded called Impactia, which is focused on the social impact aspect of things. We want to move to consciousness. So this is a bit tricky because many people don't even agree what is consciousness. But the interesting thing is that if you look at the way neuroscientists have been modeling the brain up until even nowadays, they tend to move away from a purely connectionist view. They don't really want to model, or if they start modeling neurons, they get very far removed from behavior, and they find it easier to have a sort of more modular view of the brain rather than going down to the neural level. But in fact now, we can start comparing the human brain to neural networks, and there's still a big gap. I mean, as humans we have 860,000 billion connections, and if I take Deep Lab V3, which is a fairly modern neural network for recognizing objects and images, basically. This will only have 10 billion connections, so we're still well ahead. Probably, even if these things are comparable, which they're probably not, probably the human brain is another 100 times more complex than that. We're still moving towards that, and of course, computers have this really big advantage in that they can do millions and millions of calculations per second, whereas we as humans can only do a few taken to the extreme. So they're often much faster than we are. And generally, when you start looking at the human brain as a bag of neurons which you just basically stimulate in such a way that consciousness emerges, then of course you start wondering how can we achieve this with the neural networks? And to cut a long story short, basically the reward for DAI shouldn't be at the end of the game exploring the world, it should be proving to itself that it exists. And that is the reward system we're working on, and we believe that by working towards that, art will emerge with its own accord. Thank you.
Eventually.
Can you just clarify impact IA?
Intelligence artificielle, it's very active in the French part of Switzerland.
So this is an organization that you're located in Lausanne?
We're located in Geneva. I work in Lausanne, live in Geneva, and Jonathan lives in Neuchâtel.
The major goal is to make the society more aware of impact of AI?
Yes, it's to help individuals and companies transition from non-AI to AI ready to fully AI empowered.
While not firing all of their...
No, by making society a nice place to live in, sorry. Because the concern always is that this type of innovation will potentially reward the few and make life a lot harder for the rest of us. We want to make the goodness shared equally around everyone.
Sorry to say that we missed, unfortunately, the DAI system actively outside of this room here. The team of 3 proposed to bring it here. It was too short of time to organize it, but they were willing to bring it here and to show it in action. So thank you very much for that idea. I think there will be some maybe future for it, so you can present it in another day or so.
Thanks.
Any questions? Yeah.
Did you train the AI in a virtual software environment as well as in the physical environment, or just?
So yes, we did. It didn't work particularly well, and we dropped that approach. What we're doing, because you can create this wonderful theoretical model of DAI, but in the end you have all the friction of the movements, all the reactive mechanics, the flaws, and what we're doing now is we're using all the data we collected to train a neural network which simulates DAI's physics, and then we can integrate that neural network into a fully derivable stack and do quite a lot of things with it.
Also, it's really interesting that it's evolved in real time. Like only when it was actually performing in front of people, only actually in the real world. And I think that's been an amazing way to start the project. Although it wasn't exactly what we intended in the beginning, but it actually turned out to be much more interesting that way, I imagine.
You mentioned that DAI made progress. How do you define progress?
Well, I should show you the video, but I turned it on the first time, and it was like, and the video that you just saw, where it's actually moving fluidly, and it can flip from one wheel to another, and it's not all of these things. When we took it to Dublin, the novelty there was that there were walls. And the Tinkerly Museum, I don't know if you know, it's an amazing space, and it's vast, and there were no walls that it was going to encounter. And in the Trinity College where we were showing it, it's quite small. You know, once the audience was in there, it was even smaller, and there were walls. So we decided we just